50 years ago, humans went to the moon with slide rules, courage, and computers weaker than the smartphone in your pocket. That was Apollo.
And today, we are going back. But it's not just a reboot of the 60s, is it? We have better technology, more experience, and a new name, Artemis.
Exactly. But here is the critical difference. Artemis isn't just a single mission to plant a flag. It is a carefully engineered sequence designed to answer one massive question. Can humans live and work in deep space sustainably?
So it's not a sprint, it's a marathon. Let's break down the steps. It started with Artemis I, right? The one with no astronauts?
Correct. The foundation. We launched the SLS, the most powerful rocket ever built, and sent the Orion spacecraft beyond the moon. But we kept the seats empty for a reason.
Because you don't test an airbag with a passenger inside. You needed to prove the machine survives before you risk human lives.
Spot on. Two things defined that mission. First was biological survival. Even without a crew, mannequins packed with sensors measured radiation and extreme G-forces. Second was structural survival. We had to see if the heat shield could handle re-entry at 40,000 kilometers per hour.
And since Orion survived the heat and the radiation, the answer was yes. Which brings us to Artemis II, the humans' return.
4 astronauts will orbit the moon. But, and this often surprises people, they won't land.
That actually makes sense. In deep space, there is no rescue mission. If the oxygen recycler breaks, you can't just open a window. Artemis II is about validating life support systems, right?
Exactly. It transforms engineering models into human reality. They will test navigation, carbon dioxide removal, and manual control. This is the final exam before the main event.
Artemis III. The historic landing. But we aren't going back to the equator like Apollo. We're aiming for the lunar South Pole.
The South Pole is extremely challenging to land on, but we have to go there. 2 reasons explain why. First is preparation. We're testing whether humans can live off the land by extracting water and oxygen from lunar soil. Second is resources. Permanently shadowed craters may contain water ice.
That's the key. Full resource utilization. If we can make fuel and air on the moon, we don't have to carry everything from Earth. That's essential for Mars.
Precisely. And to support all of this, we are building Gateway, a space station orbiting the moon, a laboratory for reduced gravity, and a staging point for deep space missions.
It sounds like humanity is practicing for life between worlds. And the best part? It's not just one country this time. It's a global effort.
That is the most hopeful part. Artemis proves that hope can be engineered. When we test life support systems, we protect future crews. When we study lunar soil, we pave the road to the red planet.
So we aren't looking backward at Apollo. We are looking forward.
The moon is our laboratory. Mars is our destination. And Artemis is how we get there.